We are finally in the last question of the writing part. It is to find the confidence interval using t-distribution or the normal distributions. Generally, we find using normal distribution. This is a bit more accurate method, you can say. Now, I will tell you both the methods. There are only two types of problem: normal distribution, t-distribution, and both are so similar. So let's solve one problem very accurately. First thing, you need to read the problem and understand what is given to you. A sample size of 85 New York City residents, N is 85. Okay, the average commuting time to work was 36.5 minutes. That is the average, that is mean, mu or mean. You can also write it as x and bar over here, x dash. That is also fine, but generally we write it as mu. And then they are telling the standard deviation of previous studies was, standard deviation is sigma, the small it is sigma, 11.3. Find the maximum error of estimate for a confidence, 99% confidence level. That means we don't use this 99% anyway. We use the value of gamma, that is basically this is 99%, that's 0.99. So gamma will be 0.1. Then create a confidence level interval for the mean commuting time for all New York City residents. With all this information, you can find the confidence interval. So given is just noted, but in your exam, it's better to write the given as the step one. You can just write mean as 36.5. Just the values is enough, no need of units. Sigma is 11.3, n is equal to 85, gamma is 0.1. From confidence level, it's just like the not confidence. It's basically 1 minus 99%. That time you'll get 0.1. So then now, with all this, you can't find the z critical value. You can't find the z critical value. This must be given. Now, in the exam, you are supposed to be given either the direct value of z for this gamma by 2. So this z value will be given to you. I'll just show you the table. It'll be either like this. A table will be given where confidence interval will be mentioned and the z values are known. So you can directly use it like this. This is for 99%, so it'll be 2.76. You can see over here the z critical value, 2.576. Otherwise, they might give you something like this. I have mentioned it in one of the problems. See here. They might give you in the question itself, z critical value for 98% confidence level E is 2.33. I just got it from online, but in your exam, this must be given. There is no way you can memorize all the values. There are various values for different confidence levels. If it is t distribution as well, this value is different. It's not the z value, it's t value over there, and that must be given. Otherwise, you cannot solve it. Anyways, we'll go back to the question over here. So we have all the given information. This one, I'll just note it out from here. That will be equal to, for alpha is 0.1, but that will be divided by 2. You just divide it by 2, it will be alpha by 2 is equal to 0.05. But you don't need to do all that because the table directly gives you this value. What is it? 2.576. So that will be the z value. Now then, after we have the z value, after we have all this information, there's the next step. This can be considered all as step 1. So step 2 would be standard error. Standard error. Now what you're doing is, I'll just write it as SE so it's easy to write. Standard error is basically standard deviation divided by square root of n. We have done this before. In the question 19 or 20, we have done this. So we are to just plug in the values here. What is this sigma? 11.3 divided by square root of 85. Let's put in the calculator and see what is the answer for this standard error. So it's 11.3 divided by square root of 85, and the answer is 1.226. I'll just consider it to be 1.226. You can take 4 decimal, but I've just taken 3 decimal points. They have not mentioned to round off to any value, so let's, final answer, we'll just round it off to the nearest tenth of a minute. So that's point, some only one value. Now then, after this is done, the next step, step 3, would be margin of error. I'll write it as ME henceforth, margin of error. But in your exam, it's better you write this. See, step 1 is given. Okay, step 1 given. This is all the given things, and this must be given to you, otherwise you cannot solve it. Okay, at least they must give you the table, then you can just find it from the table. This is all given. Step 2 would be standard error, and step 3 is margin of error. Now this is given by a formula, ME equals, now what is the z value, that alpha by 2, that is multiplied by whatever you find in this second step. You can also do one thing. Some students would like to write this as a separate step. That is also fine. Usually write step 1 is given, or given is not a step. This is just step 1. Okay, given is just given. Step 1, step 2, and step 3 would be the multiplication of step 1 and step 2. Basically, it's the multiplication of the z value and whatever you found out in the standard error. So that's it. So whatever you find in order, z value, standard error, multiply them, that would be the margin of error. So margin of error over here would be 2.576 multiplied by 1.226. Now let's just put in the calculator, 2.576 times 1.226. And we are getting 3.158. So I will write this 3 decimal points only. So the answer is 3.158. So we found the z value, which should be given to you. Standard error is done. And now we got the margin of error. Now, once you have the margin of error, that's it. Step 4 is the final step then. Confidence interval. Confidence intervals. This is what they are asking you to solve, right? The confidence interval. It's basically the mean. What is the mean? The confidence interval CI will be mean minus the margin of error and mean plus the margin of error. These are the two values. That's the interval you're getting. Lesser value, lesser interval, higher interval, the limits. So let's substitute the values now. 36.5 minus 3.158. Let's take all the 3 decimals. And over here, the next one will be 36.5 plus 3.158. Let's find the values over here. So all we do is 36.5 minus 3.158. Answer obtained is 33.34. I'll take 2 decimal. This mean is either greater than the lower value, but it must be less than the higher value. This is the interval, right? Now all I do is I just add it up over here, plus, and it's 39.6566. It'll become 39.66. So that is the interval. So that would be our answer. Let's just look into the final answers to verify. Let's go step by step. First, to identify the given information, everything will be given. And the z value, this table must be given. You just write it out. Don't write it as a step. For your exam, this must be given. And then this is the important step, standard error. We found that out. I think so. We rounded off to the nearest 1000 and we got 1.226. So our answer might slightly vary because over here they have not rounded it off. So that's why they have got margin of error of 3.16. And then when you find the confidence interval, these are the answers. I think so. We got the, yes, accurate value. It's just rounded off to the nearest tenth of a minute. So if you round off 33.34, it's 33.3. And less than mean will be over here, less than 39.7. Yeah, we got the exact values over here. Now, what is this 3.2? That is the margin of error. That was step 3. Look over here, the margin of error. If you round it off, it will be 3.15. That's 3.2. So we have to write the margin of error and the confidence interval. That's it. That'll be the answers. So this is it. You do nothing else. If you just follow the steps which I just written over here, that is more than enough. You will get full marks. So this is the normal distribution method. Let me just do this problem because over here the confidence level is different. And anyways, it'll be a practice. So the step one, I'll not write it as step one. I'll just write it as given over here. So given from the question, n equals 50. Then what do we have is mean is equal to 208.6. Standard deviation is 22.5. Confidence interval, that means this gamma is basically 0.02. And this means this will be equal to, now this is, sorry, it's not 0.2, it's 0, just 0. Yeah, it's 0.02, my bad. And that will, this is the answer, but alpha by 2 is equal to 0.01. Now you do not need to do this because you won't have a, you will be given a table directly. You can find the value over here. They'll generally give you the table for confidence level itself. Okay, but if you had the logbook, there's a book where all these values need to be found out, and then the exact value will be matching, and then you choose the value. If that was the case, you had to do this alpha by 2. I was telling this as gamma, it's really alpha. I'm sorry for that. Anyways, let's look into the z value because I do not know what's the z value. Here they have told the confidence, for the confidence interval 98%, z value is 2.33. So I'll take z alpha by 2 is equal to 2.33. Okay, this is it. Now we can consider this one as step 1. Okay, that's the step 1 z value. You can tell that's it. Step 2 then will be standard error. Standard error, you can just write it as bracket SE because we have to repeat the standard error formula is equal to, always, this doesn't change. This is it. It's n, sorry. N is the sample size. Now you just substitute the values. What do we have? 22.5 divided by square root of 50. And after standard error is found out, we find the step 3, that is margin of error. I'll directly write ME. Margin of error is basically given by the multiplication of step 1 and step 2, that is z alpha by 2 multiplied by SE. So we know what is z alpha by 2, but once we find the standard error, we can write it out over here. Then the step 4 is the final step, that is the confidence interval. Confidence interval over here. And that will be just the mean minus ME, and also there's one more, mean plus ME. So whatever the answer we get will be it must be less than mean and greater than mean. So there's a least value below which the mean cannot go, and then one more maximum value below which above which the mean cannot go. So that is the confidence interval. We have to find two important things, that is the margin of error and then the confidence interval. Now let's put everything in the calculator and solve it one by one. Over here, first thing is 22.5 divided by the square root of 50. The answer would be 3.182. 3.182. I'll just take three digits after the decimal point. And over here, we multiply this 3.182 times 2.33. So that will be 7.41. 3.182. So this is going to be 7.414. And over here, then we have mean 208.6 minus 7.41. And 208.6 plus 7.41. And then all we do is 208.6 minus 7.41. The answer over here is 201.2. I'll just round it off to the nearest 10. 201.2. And the maximum value will be Just add this up. It is 216.0 itself, 216 basically. So that must be the answers. Let's look over here. See, now our answers are not accurate. It's 201.3. Why? Because, see, the standard error, the values which you have considered, one more thing, the confidence interval is generally more values. It's rounded off. Maybe this was, say, 2.25. Imagine it was like that. And then over here we have 3.18. Oh, sorry. The answer would be, you can see the answer varies a lot. Now it's very low, but if you had taken the accurate values, now this I just plugged in from the internet. But if you had an accurate value, it might be 2.8. I'm not sure how much is the value, and multiplied with 3.18. See, you will get a more accurate value. It was like, it's now much more accurate, 7.25. I'm not sure what is this exact value, so this is why it's not exactly correct, but it's overall, you can see it's almost correct. You can see the values are almost correct. If you write so much, it's fine, because they'll understand, because we have taken more or less decimal points, more digits after the decimal points. That's the reason. A little error, that is absolutely fine. But overall, answer is almost right. So that's how we solve this. We need the confidence level Z critical value, otherwise we cannot solve this. Similarly, please do try these problems by yourselves, same like what we have done in the past two problems, and then check the answers here. All the answers are given over here. So this one as well, and over here also. And this is as well the same thing. All the standard deviation, confidence level, mean, n values are given. So it's very easy to solve these. Now, what about this one? Determine whether the normal distribution or t-distribution should be used for each of these questions. Then find each confidence interval given the following information. Now here there is one thing. You may see it as S. Now what is this S? We have seen S and we have seen sigma. So the difference is very simple. This means it's sample standard deviation, and this means it is population standard deviation. Now you do not need to know this information, but I'll just tell you what exactly the difference is in simple words to make you understand. Now imagine there are 100 people in a study, and you know the data of literally every people, all the 100 people, the population, entire population's data is known. Then the standard deviation known would be population standard deviation. This is more accurate. Whereas S is sample standard deviation. Now imagine in this they have taken a subgroup, okay, of 20 people. Now we know only of the sample. This is not sigma, it is taken as S. That is the sample standard deviation. So now that is one thing. And what is the difference between normal distribution and t-distribution? They're almost the same, but the graph will little be different. This becomes a bit bigger in terms of t-distribution, whereas normal distribution, a normal distribution curve, right? There are a little bit of differences, but the most important difference is normal distribution is done when you have a bigger set of data, and bigger means n must be at least greater than 30. When you have n less than 30, or you can consider it to be less than or equal, if it's 30, it's up to you. You can go with any. But when it's less than 30, we are 20, we always go with t-distribution. That's the thing. And with t-distribution, there is a little bit of difference. I'll just jump to that and then I'll solve this in detail. See, over here they have written, when it's less than, say, 30, you always go with t-distribution. And now, also there is one more thing. When S is given also, you can go with t-distribution. But imagine the sample n is 100. And then S is given. Don't worry, whatever we did in the first two questions, just solve it like that. But this one, you cannot solve it like that. Here, there is one extra step. This is, I just wanted to show that one. Yeah, degree of freedom. I could not recall the word DF, degree of freedom. It just went off my mind, so that's why I came over here. The thing is, since the n is small, over here to adjust some corrections, we do a degree of freedom n minus 1. This df means degree of freedom. All you need to do is whatever n is given, it should be less than 30, right? Subtract 1 from it. That'll be 19. And then what is alpha? Alpha is given by the confidence interval. Now, if it's a 90%, that means it's 0.9. So what is the alpha value? It'll be 0.1 here, and divide this by 2, it'll be 0.05. So that will be the alpha by 2 value. Sorry, alpha by 2. Now, with this alpha by 2 and degree of freedom, you need both of these values, and then you get the t distribution critical value. The t critical value, that's considered as t alpha 2, must be also given in a table. In your exam, if this comes, they have to give this to you because you cannot memorize it. So this must be given to you. Okay? And once we know all this, we can easily solve it. So I will solve this problem, but I'll just write this as well, because this must be given in the question or in a table, and you just plug in the value. Okay. Now see, since this will be given, you don't need to bother about the degree of freedom and everything, because that is not used. All the other steps are the same thing, what we did in the last problem. See, step 2, step 3 is the same thing. Only getting this is a little bit different. So now let's solve from the beginning. Because they have also told, you should choose which one. Now here I'll write, because n is less than 20, we use t distribution. This statement is important, okay? And if n is anything more than 30, just tell n is greater than 30, so we are using normal distribution. Now, already it's given, so I'm not going to write it again. This is all given. But in your exam, you need to write it out. Now, over here, you can also mention this is sample standard deviation. Doesn't make much difference. The method is almost all the same. Now then, step 1 is over here. That is t critical value for the t distribution. So step 2, here what you need to do is same thing what we had done before. It is the standard error. SE, I'm just going to write SE, that is equal to, now it's not sigma because we have only sample, that is sample and square root n. Now we have 7 divided by square root of 20. We can just put in the calculator and get it. What about step 3? It's margin of error, right? Margin of error is given by this t value, the critical value basically, multiplied by step 1, multiplied by step 2, whatever you get over here, that is SE. So that'll be 1.729 multiplied by something. The step 4 is almost done. Confidence interval. It's confidence. And that would be the final thing. See, there are two important answers, that is the margin of error and confidence interval. So this one will be mean minus ME, mean plus ME. So ME is unknown, but we know the mean value 128. See, this is also a denotion of mean. Okay, this or this, it's up to you. You can choose anything. Okay, now we'll just plug in the values in the calculator and find the substitutions. First one, we substitute 7 divided by square root 20. The answer is 1.57 here. Next one will be 1.729 times 1.57. It's 2.71. Over here, the answer is 2.71. This substitution would be 1.57, which we found over here. Now here, all we do is 2.71 on both the sides. Let's do it in the calculator. 128 minus 2.71. It's 2.71. The answer over here is 125.29. The mean must be greater than that lower value and must be lesser than the higher value, that is when we add it up over here. So it's 130.71. So that must be the answers. I think so we need to round it off to the nearest 10. Let's anyway see the answer over here. I'll just remove everything. This is first we tell it's t distribution because n is less than 30. And then what we do is we write all that is given and find the t value which must be given to you in your exam. And then now in case something happens and they have not given, really you must be known. You can ask your this observers that we need to know this value. It must be given in table or something. I think so they might, it'll be in the question. If at all it's not given, take a average estimate for t distribution, right? It's about 1.7 or something. Just try to memorize some value and use certain value and solve the problem. Doesn't matter, like 1.8, just use t alpha by 2 as 1.8 and continue the other steps. Don't leave the problem. Don't think that, okay, we have not been given, so we are not going to do it. No, do the problem. Just assume some value and do it. Don't assume very odd value. Don't take 50 over here. It's always within 1.5 to 3 value maximum, 3 point something, 3.5. So take a value within that range. So now we substitute over here, solve it up, and these were the answers, right? Yeah, we got 2.9, which is approximated to 125.3. And over here, also it is, say, 130.71. That's 130.7. That is how we solve these problems. And the other problems, please do solve it by yourself. Now over here, n is greater than 30. So you do not need to use t distribution. You go with the normal distribution here. So you can see n is 300. It's large, greater than 30, so we can use the normal distribution to solve it. And over here, now because you will be given the z value, the critical value, you don't need to do any of the procedures. You can directly get it. It'll be given to you in your exam. Let's see what's the z value. You can see it's 1.96 for the confidence interval of 95%. So this is because we are doing normal distribution. If it was t distribution, this value varies. Now then, uh, see, you don't need to worry about which distribution as well. This will be given. So just use that value, plug in, and do the same thing. Standard error is the same method. Margin of error is the same thing. Once you do those two, all you need to do is find the confidence interval. The lower bound would be the mean minus margin of error. Upper bound is mean plus margin of error. These two are the answers. So margin of error is important. See, whatever you find over here, the margin of error, 1.796. This is a very important value because you add and subtract with that value. Now don't think, okay, it's standard error. No, this is not the one. Always remember the last but one step which you find margin of error is substituted over here. See, I would suggest you to use the methods which I write. First step, the z value, second step, third step, fourth step. It's very easy to understand this. I know in your solution set sometimes it'll be bigger, even in your textbook it might be bigger, but you can just stick to this what I've written. That's plenty. You'll get full marks for this. Please do try these problems by yourselves and then check the answers. Here this one will be t distribution. The other one would be normal distribution if it's more than 30. Even over here, please solve it by yourselves and then check the answers. That is the end of all the writing part questions. If you have found these videos helpful, please share it with your friends. Let them know about this channel Best Math, where you can find all the end of term exam questions and exam lessons explanation for free. And I just want to thank all the students who like my videos, who share my videos, and all the gratitude comments. I really thank you so much. Your comments really make my day. A single thank you always puts a big smile on my face. Thank you very much. And I wish you all the best in your exams. I hope everyone does well. If you have any doubts, any clarifications, please do post them in the comments and I will get back to you.